Yeah, sorry. Okay, I'm recording now, but you guys got to check me on that. You got to check me on that. I'm so bad about that. Okay. Look what we can do here on our, I just want to show you something. Let me go back to, here, let's go back to a previous, let's go back to there. Okay, in Desmos, now watch this, you're going to like this. In Desmos, I can just put in 5x plus 3y. Now, if I do less than 12, look what it does.
Dude, I was literally just going to ask if you could do that too.
Okay. So look at that. That's pretty cool. So it shades, it's going to shade, it gives me a boundary line and it shades a region. But this is supposed to be less than or equal to. So what do you think I do here?
You click the little
equal sign.
Ah, good. I do less than followed by an equal sign, and it knows to make that a less than or equal to. And look what it did to the boundary line. Makes it solid.
That's cute.
That's pretty cool, right? So there is technology out there that graphs this stuff pretty easily. There's a program for your TI-84s. I'm not going to worry about it today, but it's called Inequalities. If you don't have that, I want to give it to you, so we'll download it on your calculators, because it essentially does the same thing on the TIs that this does, okay? One of the other nice things about Desmos is, what if I want to do something like I want to graph the line x is greater than -5? Ooh. Look what it does. It'll even do vertical lines, and the TI-84s have a hard time with that because they're not functions. Okay. All right. So how we do? When are we out of here?
10 minutes.
10. Okay. So where do we go from here? Systems. Okay. Now this is system. Sounds like it's going to be a lot harder, but it's not. It's almost no harder. What does it mean to be a system in math? Right. A system just means a collection of more than one thing. So if I'm doing a system of linear inequalities, all that means is more than one inequality at the same time. Right? So what do you think is going to happen here?
Are you recording this? 'Cause I'm
I am recording this, yeah. So if I want to graph this system of linear inequalities, what do you think I'm going to do? You tell me.
Graph them both and see where they're both shaded.
Okay, good. I'm going to graph them both and see where they're both shaded. And let's make sense of that by reviewing what we do with systems of linear equations. What does it mean to be a solution to a system of linear equations?
The solution satisfies.
Okay, good. The solution has to work in all of the equations in the system, right? So for that reason, we said if we have two lines in the xy plane, the solution to the system, to that 2x2 system, will just be the point where the lines crossed. Because isn't that the only point that works on both lines at the same time? That's the only ordered pair that's going to satisfy both. When we did the crazy 3x3 stuff with the planes, you know, if we had a single solution, it might have been that one point of intersection in these planes, because that's the only point that's contained in all three planes, right? So the solution of the 3x3 linear system was the one order triple that satisfied all three equations, right? So what about a system of inequalities then? Well, we want the infinite. This time it's not just one. It's always going to be an infinite number of them. We want the infinite set of points that's going to satisfy both inequalities at the same time. Well, what's that mean? It means the infinite set of points that's either going to be an intersection of the boundary lines, right? Or it's going to be an overlapping of the half planes, right? Does that make sense? So that's all we're doing. Now, obviously you guys can, you know, we're getting short on time here. This just means graphing each of these at the same time, okay? How about if we cheat a little bit and just do this one on Desmos? Because really all this means is just two problems in one. We're going to take that one and we're going to graph it. We're going to take that one and we're going to graph it. Right? Well, let's do this. This one's already put in slope-intercept form. Let's do this one manually. And after this, maybe we'll cheat and just use Desmos to graph these for us. Okay? At least just for today, 'cause we're running short on time. So what about this first one? If this first one's going to be blue, oops, first one's going to be blue, what are the points I'm going to use to define the boundary line? Where do I go?
-1.
-1.
Down to
Good. And we're going to go down 2, rise is -2 over +3, so down 2 over 3. So there's my boundary line, right? And now, solid or dashed?
All it.
Solid, because we're including the equal sign. So there's my boundary line. Am I shading above or below? Shading below, good. Below because we've got y is less than or equal to mx plus b, the boundary line, right? So we'll shade below. Okay. And then I think there's a way, well, okay, I'll just do this. Oh, yeah. Make it real light. Okay, good. Okay, other boundary line. This one's gonna be red.
Like the very last one.
So we go down to -8, so 1, 2, 3, 4, 5, 6, 7, so clear down there. My slope is, so we're going up 1, we're going over 2 to get another point. Solid or dashed?
Solid.
Solid. So there's my boundary line. Shading above or below? Above, okay, so above means now I'm shading all that stuff. Well, where's the part that's gonna be double shaded? I guess it didn't really work here, but where's the part that's double shaded? Yeah, everything in here, right? Everything that was below the blue line and above the red line, right? Okay, you get the idea, right? So that's gonna be, including the boundary lines though, right? Because the boundary lines were solid. So the region of the solution would look like, it would look like that,
Yeah.
okay? Everything is purple, boundary line or shaded region, okay? Right here at 10 after. Good place to stop.